Hi, this is Rawa from Chem 112, and today we're gonna talk about the valence bond theory and the crystal bond and the crystal field theory, and we're gonna draw the diagram for this compound. So let's go ahead and start with the valence bond theory. First of all, let's go and determine the charge of the iron ion over here. So we have the cobalt monoxide is a neutral compound. Cyanide has a -1 charge, but we have two cyanides, so it has a -2 charge. And for this compound to be neutral, iron must be a +2 charge. And the iron +2 charge, it has 66 electron in the d orbital. We arrange them on the 3d orbital. And let's look at the ligand now. The ligand, we have cyanide and cobalt monoxide. These are two strong ligands. These two strong ligands causes these two electrons to pair with these two. And to do so, we're gonna be adding a pairing energy. We add in pairing energy, so the iron will get excited, and now we have these orbitals are empty. So now we're gonna hybridize. And the hybridization orbital is D2sb3. And these dots over here are the electron from the ligand. So we have four. We're gonna have 4 sigma bond with the carbon monoxide and 2 sigma bond with the cyanide. And this compound called a inner d orbital complex, since we're using the the d from the inside, the 3d orbital over here. So moving on to the crystal field theory, which say that the ligand causes the d electron of the free metal ion to split or to degenerate into two energy level. One will be lower, like the T2G orbital, which have the XY, the XZ, and the YZ orbital, or it could be higher in energy, like the AG orbital, which has the x square minus y square orbital and the z square orbital. But also it says that the higher or the stronger the ligand, the larger the split. The larger the split, the larger the splitting energy. The larger the splitting energy. That would require a large energy or a large amount of energy to move any electrons from here to there, like to excite an electron. So this theory, or this theory, it what explains the color of the complex and the magnetic property that we will talk about in a second. Okay, and now after we draw the valence bond theory and the crystal bond theory, let's go ahead and talk about some of the characteristic. So is this complex is paramagnetic or diamagnetic? Paramagnetic mean that there will be unpaired electrons. So if we take a look at here at the valence bond theory, they're all paired. If we take a look as well over here, they're all paired. So it's diamagnetic. It's a diamagnetic. Is it high span or low span? High span mean that we fill all the orbital before any bearing. We fill all these orbitals before any bearing. If we look at over here, we have some orbital are empty, but we have here they are pairing. So will be a low span. Is the bearing energy greater than the crystal field splitting energy or lower? So we have a very large energy. We have a strong field ligand. So definitely we will have the crystal field ligand to be larger. The coordination number, let's do this as the number of bonds there are, because there will be some ligand that has two bonds, so it's the number of bonds there are in this orbital. We have four bonds, like it we have, I mean, six bonds, so that's six coordination number. We have six bond, six ligand, so that means six bond, it's octahedral. It's octahedral, but let's make sure by looking at the hybridization state. It's D2sp3. That means yes, it's octahedral. This shape has the octahedral. Okay, thank you guys, and we'll see you in the next video.